Thanks for having me here. If I was, as Ted was reading that, I was thinking about when I went to Climate Reality Project the first time in 2017. And so it's been more than 5 years, which is really, I hadn't realized it was that long until I was thinking about it here. So I'm going to talk about electric vehicles from a lot of cases here, from a personal benefit case, from a how they work, practical case, also from a climate perspective. Definitely, if you have questions, just ask. Don't have to wait for the end or anything. I may say that I'm going to cover that later, and we'll get to that slide. But that's fine. My email address is there, and I'll have it later on in case. I know I always have that thing where the question I'm thinking about that I really want to ask, I think about it 2 minutes after the thing ends, and I want to still ask it. So, so Dave mentioned my history with EVs, and so these pictures here kind of get me started and show my history. So up here in the upper right-hand corner, this light blue Nissan Leaf, my wife and daughter and I are in the picture there, and that's our 2012 Nissan Leaf, 84 miles of range, and that's how we got started. And when I first got the car, I would tell folks that it was our second car, it was our EV for all the short stuff. But then quickly realized that actually it was really not our second car. It was equal to our gas car. It was just that, we use it for the shorter trips, but most of our trips are shorter trips. So mileage wise, it actually served a similar number of miles as our gas car. Actually a little less because it was on a lease and we had to watch the numbers and not go over our lease amount. Otherwise it would have been pretty equal. Then in 2016, we got a new Nissan Leaf. The range went up to 110, but also the charging network was better by then. So we could start going further afield, and I could go to Annapolis with just one charge. And then in 2017 and 2018 is when we got the Bolt and the Tesla Model 3. And now we have our primary cars are both EVs. I've been to New Hampshire and Vermont to go skiing, been to Detroit for a robotics competition my daughter was in. We've been, a variety of things. Would have done more, but COVID got in the way of some trips we had planned. We still have our gas car for our daughter who's in college, but it gets, just a 1,000 or 2 miles a year is all it gets on it. But now we've embraced the EV lifestyle, and I'll get more into that as we go along. So I'm wearing two hats tonight in terms of organizations. Climate Reality is related to this, but also the EVADC. And so EVADC is a chapter of, it was the Electric Auto Association. It's now the Electric Vehicle Association. And our chapter started in 1980. The parent started in 1967. And so originally this was around DIY. It was around people taking old gasoline cars and converting them to electric. And I was really before my time being in the group, though we still have some folks around. We have someone with a 914 Porsche that's been converted to electric and a BMW Z3. But these days, most of the efforts around commercial vehicles, though there are still some folks that are doing conversions. And we do all kinds of things from public outreach and education, presentations like this I get invited to on a regular basis. We're trying to do programs in schools. COVID's made that difficult. And we also had to work on legislation and other activities to promote charging and EVs in those methods as well. So you may recognize this slide from the Climate Reality deck. Most of my slides are actually my own tonight, but I always like to put this in when I can, because to me, this is one of my favorite slides from the Climate Reality deck. And it really shows that we got to decarbonize everywhere. And while I'm going to talk about EVs, EVs are just a large piece and one of the larger pieces, but only a piece of the puzzle. And so I like to always remind folks of that, even though I know people in this call already realize that. So when I'm doing this in person, I have a little more fun with this and ask people some questions, but it's a little harder to do over Zoom. But the earliest EVs occurred much earlier than people think. So oftentimes people will refer to the EV1, which GM put out in the 1980s. Some people will realize that there were electric vehicles around the turn of the century. And during that time frame, gas, electric, and steam powered vehicles were all vying for which one would win out. But the first EV was actually in 1934. It was definitely a science experiment, not a commercial product. The batteries were not rechargeable, but Thomas Davenport created this car that ran on electricity. So the history goes way back. And then here are a few other milestones where you can see that this has been, we've been working this for a long time. And as I mentioned, in 1900, it was a 3-horse race here in terms of which type of cars would actually win the day. So I'm going to first start by getting into a little bit of overview about electric vehicles. We'll often hear different words and different terminology. Electric vehicle versus electrified vehicles. What does that mean? Some things around regenerative braking, energy efficiency, some of the benefits and charging, and what we care about from a climate standpoint, how clean they are and how they get cleaner over time. So this graphic actually shows a really nice picture looking like underneath the cars, where we have 3 different types of electrified vehicles. Now, the challenge here is there is no set terminology, no official designations here, and some manufacturers kind of mess up the nice orderly description I'm going to give you here, but I'll mention that in a bit. So hybrids we're probably all familiar with. You've got a gasoline engine. I don't think there are too many diesel hybrids, but I guess there could be. You have an electric motor and some batteries, and the electric motor provides an assist to either make the gasoline engine work, so it can be smaller and not work as hard, or so the car can be quicker, or some combination. And generally, these vehicles can't go anything on just electric alone. They require the gas engine. Then you have a plug-in hybrid, where this adds a larger battery and a plug, and you can charge up the battery externally and generally go some distance on all electric only. It could be as little as 8 or 9 miles. Some of them be in the 40, 50 range. And then lastly, battery electric or fully electric vehicles, which get rid of all the fossil fuel components, and it's just a battery and you're charging it up. And that's what we're going to focus on mostly. It gets confusing because, like, for example, Chrysler has their minivan, which they refer to as a plug-in, even though it's a plug-in hybrid. So these terms are a little bit tricky. But one of the things to watch for is if a car company is talking about some target or goal for electrifying their fleet, if they say electric vehicle, they're going to be all electric vehicles by a certain date, then it probably means a combination of plug-ins and fully electric. Or if they say electrified by a certain date, they're probably throwing in hybrids there. But again, there's no set definition, so it's going to vary. So regenerative braking. So one of the things about EVs that makes them so great is the efficiency. And while we all, we like solar and we like all these different things that are that generate carbon-free electricity, efficiency is actually kind of the best of all worlds. It's like the energy you're not using, you save is even better. And so I'm going to get into this in a couple different aspects, and I apologize in advance for some of the acronyms here. I'm still tweaking this a bit because I keep forgetting. I'm used to the terms and some people aren't, but if you see ICE cars in the slide here, that's referring to internal combustion engine. And they're very inefficient, but one of the areas is braking. When you hit the brakes on a traditional car, you're using friction brakes to slow down the vehicle and stop it. And all that energy that you're using, all that energy is lost and it's wasted. It's wasted in heat, it's wasted in the brake dust that comes off the rotors, it's wasted in all kinds of mechanical ways, and you don't get it back. Whereas in an electric vehicle, with regenerative braking, which pretty much they all have, you can actually, the electric motor runs in reverse and becomes a generator, and you can capture that braking energy and put it back into the battery. Now, there's losses here. It's not 100% efficient, but it's highly efficient, and in a gas car, you get zero back. And so, depending on the terrain, I have a nearby place where I like to go hiking, and when if I go there and drive back, I actually come home with more miles in my battery than when I leave sometimes because of the way the terrain goes. That's a rare situation, but you really can actually, gain a significant mileage back when you're with regenerative braking, and it's quite beneficial. And it also extends the life of the brakes. So there's a lot of things I'll talk about in terms of electric vehicles and their advantages in terms of cost. One of those is lower maintenance, and brakes are definitely a part of that because you are rarely using the brakes to stop. They're usually just for emergency stops or that last little bit. So the brakes get a lot less wear and tear than in a regular vehicle. So looking at a broader aspect of efficiency, this graphic is showing a cutaway view of an internal combustion engine car, and it's highlighting some of the areas where there is losses and waste. Thermal losses, combustion losses, pumping losses, friction, other things. And the key here is the box there and where I've highlighted in red, that when you take all these losses into account, the actual power to the wheels that does useful work is roughly 20%. It varies a little bit. So you're actually not using a whole lot of that energy to power the vehicle, move the vehicle forward. Here's a similar graphic for an electric vehicle. This is a purely electric vehicle. There are still some losses, but there are a lot fewer. And there are also, through regenerative braking, you can actually recover some energy. And so in this case, the efficiency ends up being around 80%. So about 4 to 1. So it's a much more efficient way to move a vehicle. So this comes up, and this now we're going to look at from an individual vehicle to looking at the U.S. energy system as a whole. And I know this chart's a bit of an eye chart, but the energy nerd in me really likes this one. This is from one of our national labs, and this is called a Sankey diagram, and it shows on the one side here we have all the different broad sources of energy: solar, nuclear, natural gas, petroleum, and so forth. The thick lines go to where they get used, and there's a number there. This is measured in quads, and quads is some massive number of units of energy that you use to measure energy uses at the country scale. And from these uses, generation, residential, and so forth, you go to the gray boxes. The light gray box is rejected or wasted energy, and the dark gray box is energy services or useful work. Well, notice down in transportation at the bottom here, we see that it's pretty much all petroleum at this point in time. And coming out of this, a little under 6 quads goes to energy services, about 22, a little over 22 goes to rejected energy. That's very close to our 80-20 rule with wasted energy. And so if you look at all these boxes here, you can see that in transportation, which is fueled by petroleum, it has the largest ratio of waste to useful work. Now, you're never going to get away from losses and friction and things, but the more efficient we can get, the better. And transportation is the place where we have the most opportunity to do that. So I've kind of already touched on this a little bit, but some benefits around electric vehicles, much lower fuel and operating costs. And my numbers here on gasoline are not based on today's gas prices. This is based on probably $3 a gallon gasoline. So that number would be much higher today. And then we have I've mentioned the lower maintenance. We've got the lack of toxic fumes. Another great thing that people love is the instant torque. So an electric motor, you'll oftentimes, you might see like in ads for trucks and sports cars especially, they'll talk about horsepower numbers. Well, it's actually torque, that's the turning force, that makes a vehicle responsive and fun to drive or do useful things like haul a large load and that kind of stuff. And the torque on an electric motor is instant. There's no delay. And that's what makes them accelerate so quickly, which is not just fun, but also can be a safety advantage. Merging onto like the Beltway or a major freeway, especially when you have short on-ramps, it's so much safer and easier to do in pretty much any EV, especially some of them, than your average gasoline or diesel car. And the other benefit is that, except for a little bit of Canadian hydro, our electricity is generated in the U.S. We're not relying on foreign oil, and I can get into some things around Russia and Ukraine and that situation if time permits or people are interested in talking about that. So I'm going to hop in and talk a little bit about charging. So there are 3 levels of charging for an EV: level 1, 2, and 3. Level 1 is an ordinary common outlet, anything you have in your house or garage. And this is going to get, this is a 110 volt circuit. It's going to get you 3 or 5 miles of range per hour. Not a lot, but if your commute's short, you can easily, if your commute's only 20, 30 miles, even 40 or so, you can easily charge up overnight. Even for a long range EV, let's say you're going to the beach for the weekend and you have an Airbnb and there's a plug outside, you plug your high mileage EV into that and the car sits all weekend, it can be fully charged before you leave. So it has its uses even for longer range cars and on longer range trips. The most common charging is what's done at level 2. This is a 240 volt circuit. Think of it as a dryer circuit or something you might have plug electric stove into. This is going to depend on the number of amps on the circuit, but the range is, I have it there on the slide, is 12 to 46. Typically, it's in the mid 20s or so. Some of the newer, longer range cars, if enough amps are present, can get it in the mid 40s. The great thing about these charging levels is both level 1 and level 2 use that same plug that's in the lower left-hand corner. J1772 is the designation for it, the standards designation. That's what people refer to it as. All the cars use that for level 1, level 2. The Teslas use it with an adapter, but the adapter comes with the car. So the great thing is you can charge these things. You don't have to worry about which one you're going to for different kinds of cars. Where it varies is when you get into level 3. Level 3, also known as DC fast charging. These are high-speed chargers. In the US, there are 3 predominant standards or types. These are high voltage, and depending on how fast the car can accept the electricity and the speed of the unit, you can get anywhere from 50 to 200 miles back in 30 minutes. There are 3 main plug types. That middle one there is what most cars today support. The Chademo one is that's in the middle of the bottom row there is going out of favor. Not too many cars use that anymore. And the Tesla one is just for Teslas. So here's where you have to know what kind of car you have and what kind of charger you're going to know if that level 3 or fast charger is going to work for you. So people often talk about charging as one of their issues around EVs. There are a lot of ways to find charging, and I mentioned several of them down here in the bottom of the slide. The picture here is from a system called PlugShare. And PlugShare is available as a website, plugshare.com, but also as an app for your smartphone. And you can put in an address or a zip code, and it will show you all the chargers nearby. You can also tell it to filter for the kind of car you have, and it'll only show you the chargers that are compatible with your car. So it's a great way to find charging. It's a great way if you're curious about getting an EV but want to know, well, is there charging where I typically travel to? It's a great way to do some research. It's very useful for travel and for trips. There are other ones here. Supercharger.info is Tesla related, and a better route planner is more for planning long range routes. It'll estimate how long it's going to take you to get somewhere. The key here is that charging is becoming more and more prevalent. It's definitely concentrated in the more urban areas where there are more people, but it's getting easier and easier to do. And I got some maps coming up. So most people probably remember the Dieselgate scandal from a few years ago where Volkswagen got caught. A couple of unique things about that scandal. They got caught cheating on emissions test. They had software that would actually have the cars run in a different mode, detect when it was being tested, and run in a different mode and looked like it was cleaner than it was under normal operations. Well, the first unique thing about that situation was they got caught. Oftentimes companies don't get caught with those kind of things. But the even more unique thing was the penalties were actually very severe. They had to buy back cars. They got lots of penalties for various kinds back to various governments. But another piece of that was they had to invest $2 billion over 10 years, and they're still working on this, to deploy EV charging across the United States. They actually are also doing Electrify Canada, even though they're not required to. And this shows their map as of this past fall. And the other amazing thing about this is it also, they lost a lot of public trust, and they also started their efforts to electrify much earlier than they probably otherwise would have. So what they did was definitely wrong and a bad thing. In the end, this may actually, we might see more benefit than the harm done from the pollution they caused. This is a real catalyst for them moving to an electrified position, and also all the charging they're doing and other things. So this is showing the Tesla network. So Tesla has what they call their supercharger network. And I've used this, like I said, to go to New Hampshire and Vermont, to go to Detroit. I know lots of people who have gone cross country or down to Florida or all over. You can easily travel in most of the United States, decent parts of Mexico, and the populated parts of Canada, and go on road trips and not have to worry about charging with this network. So it's a great way to be able to do that, and it's growing all the time. So one of the great things about EVs from a climate perspective is they get cleaner over time. And so the grid's getting cleaner week by week, and so your vehicle's getting cleaner. And internal combustion engine vehicles actually get dirtier over time. Wear and tear on the engine, plus more dirtier unconventional fossil fuels, means that our gas cars get dirtier over their life, whereas EVs get cleaner. And if you want to not worry about the dirty grid, you can always get wind power from your utility, or put up solar and run on the wind, or drive on sunshine, as we like to say, for those of us with solar panels and EVs. So this map from the Union of Concerned Scientists shows the lines here are not state boundaries, they're grid boundaries. The US grid is pretty fascinating. There's all kind of different, I can do a whole talk on this by itself. But there's different regions of the grid. Utilities are grouped together in different ways. And these are the different sections of that. And you can see back in 2014, for a gasoline car to be as clean as an EV charged from the grid, you would have to get the mileages shown here. The worst area would have been around like Colorado and parts up here, but even that was 38, and most gas cars didn't get that back in 2014. Here we move to 2018, 4 years later, and now we're almost everywhere is over 50, except for a couple little pockets. And as you can see, the grid is getting cleaner. Well, what's great about this is the EV you bought in 2014 is now cleaner because you're charging it on a 2018 grid. So briefly, I want to mention a little bit about heavy duty and other types of EVs. I'm not going to focus on this a whole lot, but I just want to mention that electric buses are really starting to take off. I'm in Frederick County, Maryland, and my county was the first county in Maryland to add electric buses to its transit fleet. A lot more fleets are doing this now. The metro system just announced an order for, I think it was like 79 electric buses to add to their fleet over the next few years. And so we're seeing lots of adoption of electric buses around the country. It's starting to accelerate. However, we are way behind. Even a few years ago, China was over 100,000 electric buses. So we could be going at this a lot quicker, but we are picking up speed on this, which is great. The other thing about electric buses, besides being cleaner, they also actually are great for encouraging people to take mass transit. A lot of people don't like to take mass transit because it's dirty and they don't like the fumes and stuff. So it's a great way to get people to actually take mass transit. Garbage trucks are starting to appear. This is actually in Hyattsville, which is near I guess PG County. They got this truck back in October. There are other ones around the country. and this might seem kind of weird, is like, how can we do these buses and garbage trucks when we're still talking about range anxiety for cars? Well, the thing about buses and garbage trucks is they're big vehicles that carry a lot of stuff. So the torque of an electric motor really fits their use case very well. And two, they go on defined routes. So you may have a garbage truck that, it's stop and go. So regenerative braking actually helps out a lot here. And it's going into a neighborhood, and it's, it moves 50 feet, stops to pick up some trash, and it moves 100 feet and stops. And it's going all through a neighborhood. And then once it gets through that neighborhood, it maybe has, a mile or 2 or 3 into the next neighborhood, and then it's doing the same thing again. So in its route, it may only travel mileage-wise 20 to 30 miles. It may not travel a lot of distance, but it's all stop and go. And it's also a known defined thing. So you can figure out what you need, size it appropriately, and it can work very well. So this is a great way, and these vehicles have outsized impact from a climate pollution standpoint, and so it's a great place to electrify. In development are semi-trucks and airplanes. There's actually, these are kind of they're a little more actually past development. They're actually, that's in the semi case, they're actually out there. They're just out there in small scale, but they're ramping up quickly. And one of the things I was surprised to read about recently is that most trucking, the distance that things travel is 100 miles or less. Because most trucking is short range from warehouse to destination, or from shipyard to distribution center. And so in that 100-mile range, we definitely have, it's much easier to electrify, and there are definitely things that work there. Long haul trucks, which are the larger amount of miles, but not the number of volume, is harder, but those are occurring, and a lot of folks are working on that. Planes, it's starting out with small personal travel planes, but others are in the works. And one of the things we're going to see is the first will happen is, small commuter planes like the one shown here. And then we might get to like the intermediate jets, to go like 500-mile, the short hop flights, 40, 50 people. Those are actively in development. It's unlikely with the current technology, we're not going to see like 747s electrified, but we might see hybrids where it's it's an assist, so you need less jet fuel, or possibly could you be electrified with use of hydrogen or other options. So a lot of research here, a lot of potential in these areas. So I want to get into some bigger picture things here next. And when we talk about electrification, and increasingly, as I work on this kind of stuff, it's not just electric vehicles, but electrification across the boards. And so, if I have a 2-word answer to working on climate, it's electrify everything. And there's a lot of things here that come into play that really help us. And one of the things, and we probably all have seen this and use this when we're talking to folks, but the great thing about some of these things now is that even back 5 years ago when I first was doing presentations, it wasn't the case that you had to like fight for solutions. But now you have economic and health and other benefits that you can, even if climate weren't on the table at all the solutions that we all push for have value and we want to do anyway. Climate is just the reason to do them fast. And so one of the things about gasoline cost is that the price volatility is really kind of crazy. And this actually, I need to update the chart. I actually did this back for a presentation in February, and the chart's out of date. But what you can see here is that the price of gasoline is all over the place. This volatility is really hard for businesses that use a lot of fuel, fleet operators. It's also really difficult for folks on a fixed income or low income folks, because fuel prices have an outsized impact on their budgets. For people in a middle to upper middle income bracket or higher, they don't necessarily like paying more money, but it doesn't really, affect their budget like it does for low income families. Electricity costs are much more steady, much more consistent, and so that volatility, which becomes challenging to deal with. Also, Transportation is currently our largest sector in need of decarbonization. Now, one of the challenges right now, as you've probably seen, doing any kind of graphs on a lot of these things, COVID really messed with the trends and has this arbitrary these dips and spikes that are are COVID related, not necessarily trajectory of what's happening with technology. But transportation is one that's been kind of flatlined for a while. And we know how to fix most of this. It's with electrification. There are some areas that still need like big ships and stuff that need some efforts. But I'm seeing even things like large construction equipment and so forth being electrified, and so there's a lot of good potential here. So one of the other areas that gets into some economics here around this is the idea of co-benefits. And here's one of those cases where we can look for a climate solution, but it has other benefits, co-benefits, that are reason enough to do it. And this quote, which I found a couple different places, and I think it's, I found it mostly attributed to Dwight Eisenhower. The problem cannot be solved, enlarge it. The idea here being is that you can get more advocates to something if you make the problem bigger to cover the full scope of it. You can bring other allies into your effort. So we may be pushing for electrification and getting rid of fossil fuels because we're worried about climate, but others may be doing it because they're worried about air quality, or they're worried about the view, the dirty air, and you can't see vistas, or any number of other reasons. Well, one of the things we're finding is that research is showing that air quality and health benefits from electrification and getting rid of fossil fuels are really tied together, and the impacts on health are much greater at much lower levels of air pollution than we used to realize. And this was seen during COVID. You probably have come across or seen the references to PM 2.5. This is particulate matter, 2.5 microns across or smaller. And here you can see a human hair in the little graphic there is 50 to 70. So this is really fine stuff. This has serious health impacts, more than we've realized until recently. And there's been some research showing that people with exposure to this have an increased impact from COVID. And so electrification is one of the ways we can actually address this and reduce these impacts. The American Lung Association, this came out earlier this year. They had a study showing that there is over $1 trillion in public health benefits by focusing on healthy air. And so here's the case where even if we don't really if we have a community or a group we want to talk to about climate solutions, but they don't really care about climate, they either they're not too many outright deniers anymore, but they want to minimize it or even denying it in a few cases. We can talk to them about healthy air. We can talk to them about saving lives, or we can come down to cold hard dollars and talk about saving money. So there's all these reasons to do these things. We don't have to always lead with climate. EV sales are increasing, and so this is a good news story here. COVID's kind of gotten some hiccups here around supply chains and some prices going up, but despite that, sales are booming. And so in 2021, overall vehicle sales grew by 3%, but EV sales grew by 85%. So this is really taking off, and especially with high gas prices, now people see that the value of this, and it's really, I think I saw that in California, the EVs are now over 12% of new car sales. So a little bit about choosing an EV. There are lots of choices today. I have a little more of this later. But right now, the one category that's a little bit limited are trucks and SUVs. However, those are on the way and are starting to appear. Ford came out with their F-150 Lightning, which first deliveries occurred beginning of June. And that truck is getting rave reviews, and they can't make enough of them to keep up with demand. And the great thing about that truck is a couple things. One, day one, it's a better at being a truck than old F-150 gasoline and diesel trucks. And two, it is going to bring in a whole new group of people who would not consider electric vehicles when they see what it can do. And it's going to widen the audience in a lot of ways. That's great. So I've kind of mentioned a lot of this already. I want to highlight the one thing at the bottom there. If for yourself or when you're talking to other folks doing presentations or outreach, one thing to be aware of is that we don't do this in a lot of areas, but we do with vehicles in ways that just aren't logical, is that we want a vehicle to be able to do everything we want it to do. And sometimes we'll let that one use case drive what we get. I mean, just look at the amount of trucks on the road. Not everyone who's driving a truck actually needs or uses a truck very often, but they want to be able to bring that sofa home from the store or help that neighbor move. But how often do they actually use it as a truck? If you're using it as a truck, by all means, it makes sense. And if you want to get a truck, that's perfectly fine. But what I'm saying here is don't let that one or two special use cases be a roadblock to going electric. If you find an electric vehicle that meets all your needs, except for you've got 2 trips to grandma's, during the course of a year, well, you can rent a vehicle for those 2 times, and you'll, even with those rental costs, you'll probably still save money anyway on maintenance and fuel costs. So we do this with vehicles more than anything else, where we let outlier requirements dictate what we choose. So in summary, this is fast moving and it's underway. I used to have some slides around all the manufacturers have announced, so many electric vehicles of sales by a certain date, but there are just so many of them, can't keep up. And even super high end, Bugatti and Rolls Royce and even those kind of companies are jumping on this bandwagon, and it's happening fast. As I said, announced plans keep coming. The benefits are not just clean; they're also quiet, efficient, and great performance. It is still the case in some categories that the upfront cost is higher, but lower operating costs make up for that, and the upfront costs will come down, not quite as fast as we'd hope because of COVID and supply chains, but they will. And there are dozens of models and more on the way. And I already mentioned the F-150 Lightning. And one of the things here that really tells me the tide has turned is, if I go back about 2 years, you never saw an ad for an EV on TV or in magazines. And now you see them all the time. And I'm starting to notice that, because I focus on this, I'm noticing cars in movies or TV shows where the person's driving electric, and it's not for any particular reason in the story, they're just happen to be electric. And so people are starting to just choose those, and that's just a sign of the acceptance and the change. So I mentioned all the models available, and I want to highlight this. This is, so my EV group, we put out this info sheet, and we just updated it back in late April. And the sheet used to be, it's 2-sided, and it used to be one side was battery electric, one side was plug-in hybrids. Well, there's so many more electrics now that both sides are fully electric. And that's available. It has a lot of specs and so forth. And it's just a snapshot. But we put this out, like I said, 2 months ago, and I'm sure there's new ones that have come out since. So that's something to be aware of. And with that, I've one final thought. Actually, when I grabbed this deck, I grabbed one where this is what I normally use for EVs on Earth Day. But it's not Earth Day, but I'll mention this anyway. This is the blue marble photograph from Apollo 17. And one of the things about Earth Day is that we think about it as saving the Earth, but the Earth will be here no matter what we do. We really should call Earth Day compatible with humans Biosphere Day, because it's really about saving ourselves. And but that doesn't fit on a bumper sticker, and it doesn't roll off the tongue. And so this is one of the solutions we can use, both to help ourselves personally and help the planet and help our health. And one last thing I forgot to add to this deck, I keep meaning to, I want to mention, and I don't have a slide here for, is the goal here was electric vehicles, but I wanted to mention, I'd be remiss if I didn't mention electrifying other things in your home, things like your lawn and garden tools and things like that. Electrify everything. And someone mentioned as we were joining in, Rewiring America and some of their efforts. They have some great guides around that. And so electrifying vehicles is just one piece of this. There's so much else to do, and we can talk about that as people want to. But that's what I have. Thank you very much.